I decided that we're going to take a little bit of a detour from and start kind of introducing some topics on efficiency, especially since Chapter 7 is going to be starting to talk about things like safety and speed and the compiler macros, which we'll dig into a little bit. But before we do a lot of that, often coming from other languages, whether you use, especially statically typed languages like, say, C, C++, Java, and so forth, when you start talking about efficiency, one important topic that comes up is kind of data layout and how things are kind of represented in memory and so forth. And in order for us to actually get into that kind of topic, um, at least from my standpoint, from my experiences, one must kind of understand the type system that you're kind of dealing with, and sound sort of like the promotion rules and so forth, and how that kind of helps influence the structure of not only like Lisp structures but also like classes even to an extent. So I started doing some digging, and I decided that introducing the type system at this point might be a good time, and even at some point introducing things like type case, e-type case, and so forth. So to begin with, I wanted to mention that, like at least according to the Common Lisp standard, and I'm sure Elijah and Michael will probably chime in here to correct me if I'm wrong. A lot of there are Lisp data types, and then there are Common Lisp classes, and they're kind of unified together when you start using the Common Lisp object system, right? At the end, like when you look at any like value or that's inside that's been instantiated inside your Common Lisp image, that's actually an instance of a particular Common Lisp class, but it really also, if it's a primitive, has an associated type, which is a class.
So allow me to hop in there.
Yeah.
Actually, so every object is of a particular class and belongs to one or more types. Every class has a particular type
of the same name.
And every object is of the type of its class, or named for its class, and of the types of any of the superclasses of that class, and possibly in some number of other types. And there are ways of making types describe just about anything. So you can construct a type for a particular object to be in fairly easily.
Okay. So the numeric types, just to kind of bring these into kind of concrete terms. So there are numerical classes, right?
Yeah.
That, well, first we can't extend. We're not able to subclass from them, but there are also equivalent type objects that are extending those numeric classes. Is that what I'm understanding, or
no?
Okay.
So every numeric class has a particular type of the same name, and there are also some particular extra types that can be more specific than just saying the type corresponding to anything of this class.
Okay. All right. That makes sense. So like there's an additional there's the restrictions are of the types that
yes.
of this generic top level class.
For instance, there's an integer class and a type.
Right.
However, as you just saw with SBCL, it specialized that integer to be within 0 to the maximum fixed num size.
Right.
That's a specific type using the integer base type, restricted to those bounds.
Right. So, but the way you would, but that, let me go to my Emacs buffer here. That bound here is, so this is a standard, for folks who can't recognize that, that's a 64-bit fixed num, although the first 2 bits of the 64-bit integers inside Lisp data types are related to tagging information
On SBCL.
on SBCL. I don't know. I think CCL does it too that way as well.
Possibly, hard to say. I've never checked.
Yeah.
Yes, it does.
I think it does the same thing. Although I think it's a much
Also,
larger value.
it's different on 32-bit SBCL, of course.
Yes. Each one is going to be different. I'm running the SBCL 64-bit here. For folks who are running, like say SBCL on your Raspberry Pi or whatever, you will get the 32-bit fixed num in there when you try to type in type of. You will not get this value. But again, whether it's 32 bits or 64 bits, one thing is that needs to be known is in Lisp, the Lisp image and the way the Lisp architecture works, it needs to keep type information around for some of its values. So the first 2 bits of the format, at least in the more active, the more well-known like SBCL, CCL, I even think ECL to an extent, but I got to go and double check it. They actually use a tag-based architecture. That's a common architecture to implement a Lisp, and that's those bits actually keep some sort of information around so that you can go do further introspection. And in some cases, I think they also use it for optimization. But let's kind of like introduce a couple of things. As you guys see in my Emacs buffer here, I've done a couple of the stupid things here, but it actually brings up a couple of the basic numeric classes that are around. You have
actually CCL tags it with 4 bits.
With 4 bits, okay, interesting. Okay, I did not know that. I thought it was 2. That's a I thought it was 2 for some reason.
Most positive fixed num on CCL, I believe, is 60 bits.
Okay. That sounds about so. Okay, so that means. Okay, that makes sense. Okay, so this is the if you're on CCL, this is your maximum fixed num size. Obviously, with SBCL, you get a little bit more. Since it's 2 bits instead of. Let me try and see if I can copy that.
And of course, that's on 64 bits.
On 64 bit, yeah, that's on 64 bit.
Rom, go into your inspector. Okay, too late now.
What are they?
Go over to your inspector.
Okay.
Put your cursor, your Emacs cursor, over the number you want.
And yay.
Hit Alt Enter.
Now I can do it. Okay, that's cool.
And now you can use it like #v or a star, yeah.
Well, since it's immediate, it's easier just to use a star, but a #v is certainly another way of going about it. Too. All right. But you see the differences here. In CCL 64, you get 60 bits with the 4 bits. So that means in 32-bit land, if you're on, again, like Raspberry Pi or any sort of ARM32 processor, it will be a 32-bit fixed num with the first 4 bits being used for tag information on CCL, or it will be a 32-bit fixed num with the first 2 bits being used for tag information on SBCL. ECL, I think, follows the same thing as SBCL, at least I think. I have to go and double check that, but I'll leave that as an exercise for folks who are kind of like interested in looking at those different sizes. These are important to kind of just keep track of only when you hit certain like edge cases. Like if you're doing a lot of your day-to-day stuff, you may not hit these kind of limits. But again, as we start getting into more topics of efficiency, knowing this helps understanding how kind of stuff could be laid out in memory by the different implementations. We also have, standard float types, like, this is single float. I think there's also a double float. There's, although I got to remember how to actually get it large enough to become a double float. Things like 100,000. No, it's still single. I have to go on like a huge little number to actually get it promoted to a double float. We have all the basic floating point types. We have additionally two additional types, which is your rationals and your complex numbers. Now, I'm not sure, but there are libraries that give you those types in other languages. But these are built into the Common Lisp standard that you can leverage. So the way you would specify, say, a complex number is you use a reader macro. I think that's a reader macro.
Yep.
And
type of.
Do I spell? Oh, yeah, that's right. Thank you. I should have. You use the reader macro, and it'll actually go ahead and create a complex instance for you. There's also a way of actually. Isn't there like a way of actually specifying make a complex number like?
I believe it's just complex. I could be wrong though.
Yes.
Yes. 2 and then 1. And we could do it that way. That's another way of actually creating complex numbers. Rational numbers, of course, people have seen this. If I do type of this guy, you'll see that you can get your rationals. There are quite a few detailed types that you can actually leverage inside the Common Lisp standard that will really help for numeric typing. But there's also, and we've already talked about how to define user-defined objects using like CLOS in previous episodes. So I'm not going to really go through those here. But one thing we haven't kind of talked about is how do we actually define like our own like special types? Like if we wanted to like create like say a type alias. Let me quit this. So the way to do this is you have this concept called a deftype. Now deftype isn't just for creating aliases. You can actually use deftype to create what I see in other languages look like type constraints. So if it you can specify like a predicate that says if you actually satisfy these constraints, you are of this type automatically inside Lisp and notify Lisp of those types of systems. So let's say you wanted to create the simplest one.
That's just to be clear. That's actually just part of the satisfies type.
Yeah.
Deftype can be used to alias the satisfies type though.
Oh, that's right. Okay, so satisfies type is a different form, but deftype could be used to used to create those aliases. So let me see.
You need parens. You need an arg list.
Yeah. Integer, I think is.
What are you trying to do?
I was trying to make a simple
So my int. Empty list of parens. Quote integer. There you go.
Is that it? Hold on. Let me go and double check that. Yeah, that's right.
At least I'm fairly certain that works. Been a little while since I've defined the type.
So you have you have some sort of lambda list that you could specify inside of it, your argument expressions, and then your basic type parameters. I'm looking at the documentation here just to make sure that I'm not messing this up.
So types are S expressions.
Right.
Right?
Right.
And so deftype really defines a type macro, in a sense. It's a bit trickier than that just because...
Can I macro expand this then, you're saying?
Yeah, it's basically a macro expander. Well, I mean, everything's a macro. I don't know if you can use macro step to expand a type macro. But every def form is a macro, so that's not going to give you much.
Yeah. This isn't giving me anything other than the fact that SBCL's implementation has a compiler def type here that...
Right, yeah.
Yeah.
But no constant type expander.
Yeah.
But yeah,
so,
collapse that. That's not getting you anything.
Yeah, they're giving you nothing. Okay.
So if you so you can give args to that, and that's how you can define a compound type specifier.
Right. Okay. So like if I so the one example that I think would be great is let's say that you wanted to create, you know, what I'd say counting integers like on your hands. Okay. Like let's say that we created something that we know that you can only count from 0 to 10 if you're using your hands, although it's
Sure.
so let's say that we have something called hand counting integer. Okay, we need to be able to restrict this guy between 0 and 10. And the way I remember, because I did this before. I think we basically do the restriction bounds on the integer type here, and this.
Well, you need to quote that, but yes.
I need to quote this. Let me just see what the compiler thing is. The function integer itself is under. Oh, right. Okay. All right. So now, if I do type of, say, 0,
it'll still say integer or bit.
Yeah, it'll still say bit.
But you could use type P.
Oh yeah, type P. If I do type P, hand counting integer, which allows for folks who haven't seen type P, just going into the type system and checking to see if this satisfies the particular constraints of that type. And I pass in hand counting integers, you can see that 0 up to 10 is they're all hand counting integers, but if I go above that, it'll go ahead and return nil for you. You can also do, but introducing this hand counting integer also allows us to actually look at some other interesting predicates. So we just saw type P. You can also check to see if this is a subtype. So subtype P, I think I have to say hand counting integer to integer, and you'll see that it returns two values. The first one is what was it? The first value that's returned is whether or not the type 1 is actually a recognizable subtype. And the second value is returning a certainty value, which I've never actually leveraged before in the past.
It has to do with whether or not the system actually knows that type 1 is a well-formed type or not.
Okay. So it won't give you like a confidence number, would it? Like, or it just says...
No, it's just true or false.
It's just true or false. Okay. Okay. That's because I've never actually used some type P. I've used type P in the past when I was playing around with this type, the deftype stuff before. The other thing that you could use is, as I mentioned, let me just skip this. Let me switch. Why are you not giving me? There we go. Is what Elijah alluded to earlier is satisfies, which gives you the ability to actually, specify some predicates. What it does is according to the ANSI standard actually is it takes this set of all objects that satisfy the predicate, and his symbol is going to be a global function that takes in a single argument. So you can have like functions that gives people some sort of indication of whether or not something is of a particular type, and then you can actually pass those predicates into satisfies and use that to actually go in and check to see if the values that you're passing in is of this particular type or not.
It's important to note that that's normally only really used for sanity checking and is probably considered a big performance trap because all that checking is done at runtime.
Right. Good point, Michael. That's a That's it's useful for further restricting though your the inputs that are being passed in, right? Like you could so one
Right, that's what I mean
yeah,
by, sanity checking.
yeah.
I mean, it's not really utilizing the type system for performance per se in most cases. But I mean, yeah, I mean, these checks are being done at runtime with satisfies.
So where performance becomes important is when you start declaring your types, right? In your functions, because when
Well,
you compile them,
well,
so
performance is a tricky topic in Common Lisp, mainly because, there's so many implementations and they're free to do so many different things that differ from each other. I mean, really, the best thing for performance is good data structures and algorithms. As soon as you get into using the
right.
type system for performance, what may yield better performance on one implementation may yield worse performance on another implementation.
Right. I mean, in general, good data structures and algorithms will get you like 80, maybe even 90% there, right? That's just regardless of language. That's something that you should try to go for. But in compiler macros, the reason I haven't introduced compiler macros here, but I'll just kind of mention it. It's some of the examples that I've seen. They brought up using type declarations and type hints to further you know control or guide the compiler to actually generate a particular type of uh, assembly. One, but I guess again to your point, that's going to be a very implementation specific topic. Like at that time, you're going to probably end up playing around with different implementations to find the one that will give you your efficiency, like kind of guarantees that you want to provide in your software system. Um,
There are a number of basic type declarations that are generally helpful when you're writing certain code,
mm-hmm.
but I mean, as a rule, when you get to the really non-trivial type declarations, or like when you start declaring a value as holding an instance of a particular class, that you've kind of lost it at that point.
Right.
Struct type declarations tend to actually help with performance some, but even then, hard to say. It also all depends on the optimization settings and what your particular compiler cares about optimization-wise.
Okay. Interesting. All right.
Perhaps the type declaration that Michael and I are most familiar with is simple array single float of 3 elements.
Or 2 or 4, depending.
Or 2 or 4, yes.
Right.
That would we're using literally all the time, and declaring the element type of a simple array of fixed length is usually the most effective you can do across implementations, especially if it's specifically like an integer type of fixed size or a float type or one of those, because that's the sort of thing that is unlikely to get you poor performance on an implementation that does something stupid, and is likely to get you good performance on implementations that know what you're doing. So, it's hard to go wrong declaring the element type of a simple array as being floats, as being a single float, right? Especially if it's a fixed length array. It's hard to screw that one up. And it can get you a lot of performance in like optimizing away bounds checks and stuff like that.
Okay. So you're declaring. So can we let's so you're saying in like in a function, like let's I don't know some values in array. That's the stupidest example, but you know what? I can't think of one right now. All right. You're saying if I could declare here, I guess how do I guess do simple array here? I'm trying to declare that variable to be.
You can't do it like that. Complex types that are an S expression like that.
Yeah.
You need to use the type declaration for that. So it would be the
Would it be easier just to go ahead and do a deftype here and then say?
Well, I mean, you could do that. I mean, it doesn't matter. I mean, for one-offs like you're doing, I would just type it in the function in the declare form.
Okay. So you do.
But yeah, open paren type. I believe if I remember the syntax, and then it's quote simple array space single float.
All right.
Open paren. Do like 3, I guess.
Okay.
Yep.
And then do.
And then the arguments to that type form would be every argument you want to be that type. Okay. ARR in that case.
All right, and then we could then use that. So what does this actually? Let me go ahead and just write something stupid and summing everything inside this, even though it's a really dumb. I just want to see what generates. Okay, this guy is giving me an error.
You cannot do that. You have to do it across ARR.
Oh, got it. That's right.
Yep, the N keyword is specifically for lists.
That's right. But it's still saying.
Maybe I screwed up. What do we got here? What does it say? Undefined type, simple array, single float 3. Oh, yeah, it shouldn't be quoted. I'm sorry about that. Maybe I said, okay. Yeah, that should be quoted.
Yeah, no, you don't need to quote it in the declaration.
Okay.
Sorry, I was looking away for a little while there.
No, not a problem.
It
is saying.
What's the problem now?
Hold on. I can't really. Here we go. Wait.
No, that's old. That's old. Go to your slide compilation buffer. Space BB.
Yeah.
No.
Compiling loaded no warnings.
Okay, yeah.
Yeah, it was just old.
Okay, yeah.
That's
yeah, do you know what I do to sort through all of that? I go to the slide compilation buffer because that only shows the warning from the most recent compilation.
So
I just put my point over the compiler note underline.
Yeah, that also works.
If I do some values in array, I should be able to get the generated code.
Values.
What?
There you go. Yeah. It's completing it for you, but you've missed the S on the value.
Oh, yeah, I'll use.
With Wilfredo, you joined us.
Just Will is good.
Cool.
Yeah.
Yay!
Can you guys hear me?
Yes, we can hear you.
So we do have a generic plus in there, though.
Yeah.
To get rid of that, we would probably have to utilize the form. Have we talked about the yet?
No, I think that's a good segue.
Actually, that's weird. SPCL ought to have inferred the type of I from that.
Yeah, that is kind of strange.
So.
Well, I mean, you can add it yourself. I mean, for I fixed num across array some I.
Do you?
Or sorry, for I single float. For I single float.
So do I put this in paren like this?
No, just put single float after the I.
Okay.
For a simple type, a non-compound type, you can just put the type right after the variable in that particular case.
Yep. If it's an S expression, with parentheses, you'd have to use the type.
Of type.
Of type, yeah, of type, that's it.
That's still actually generating a generic plus.
Yeah, that's interesting. It may just be that the way loop is written does that for some reason. If you macro expand that loop there, we might be able to see what's going on.
Oh boy. Avert your eyes, everybody.
So it's declaring the type right there into the I, so...
Yeah, and then expand the with some count.
Well, so can you...
Just keep hitting E. It'll jump you through each of the macros.
Oh, that's cool. I didn't know that.
Yeah.
That's cool. All right.
Okay. So what are you
so
doing?
The loops variable...
Oh, it's the set Q. It's the set Q. Yeah, SBCL is really paranoid whenever you set Q a variable, and it just decides that it doesn't know what the type information is afterwards.
Yeah.
SBCL is actually really dumb about that. It's a known bug. The SBCL devs have talked about it loads of times, but it would require a very serious rewrite of how they do type deduction in order to handle it properly.
So, do we get this if we up the optimization level, or are you already?
Oh yeah, up the optimization level.
Okay. Declare.
You can do that right in the same declare form.
Okay.
Yeah.
Give me just 1 second.
I'll
here.
just hit Q to close all that.
Yeah.
And then under type, do the optimize declaration.
Right. Optimize.
Optimize speed, safety 0.
Speed.
And another thing is even so.
No parens there.
No parens. Just type speed. That'll do the max speed of 3.
Okay.
Yep,
and then parens do safety 0.
Oh, okay. I actually usually say speed 3 here.
If you don't specify the value, it defaults to
undo a couple times. Hit undo a couple times. There you go.
Okay.
You were in Lisp state for too long, and you.
So I usually do this just to be
Yeah.
I mean that's
Oh, you
standard.
can do that'll make Wilfredo happy.
What?
He likes being.
I mean, I like writing it this way. I've seen this a lot, so I just usually get. I didn't notice that this was a shorthand.
I'm just lazy.
Yeah. I mean, that's.
And then if this doesn't get you what we want, then what we would do would probably be some.
Compile it one more time.
Yeah, compile it one more time. Okay, yeah.
Yeah,
so do generic plus. Oh yeah.
Yeah, but you should be able to do some the single float I. That should make it happy. So rather than you could put it up.
Oh
here,
no! I know the problem. I know the problem.
What?
Okay.
It's not one we can solve so easily either.
It's the summation, isn't it?
Yeah, it's the sum variable. Variable.
I think the sum variable gets declared with the right type.
So if you're saying, should I do D?
Try that. Yeah.
D single float I, sure.
No quote.
Okay.
Yeah, D is also a special form.
So try that. Let's see what we get from that.
Still says one note here. What is that?
Yeah, so it's the summing variable then.
Yeah.
Yeah.
And
yeah,
it says,
no, do
and it
some
says it right there.
thingy into because you can do this.
Oh, I see. Is that going to? Okay.
There's an of type for into, if I remember correctly. Or am I going mad?
Okay, so wait, I have to declare a variable to do into, don't I?
No. It creates for you.
Yeah, but I can't remember. Is it of type that you can do after that one? I think it is.
I think so.
That's
a part of.
Check real fast.
Yeah, I'm doing the same. Yeah, it's a type spec, which means
either simple type spec or destructured type spec.
So let's
so do res, and then after it, you should be able to do.
Do I do finally res?
I think you can just do single float.
Yeah.
No.
Yeah, because it just asks for a type spec, so I think you can just do into res single float.
Okay.
Sure.
I think so.
There. I think
there you go.
There. So we have to actually hint at everywhere through the.
So with this, I think that's what you.
I'm
not sure you can get rid of the.
No, even more. You can get rid of the into res. You can do some thingy single float.
Oh, really?
Yeah. You can just do some thingy some I single float.
Okay.
I almost guarantee it. If I've read the spec correctly, possible I haven't.
Wait.
Yes.
Yeah, there you go. Cool.
And did it generate the same code?
Oh, that's a little more instructions. 61 bytes as compared to 54.
Yeah, that's interesting.
Still though.
Let's see.
It probably.
Wait, is it the same number of Hold on.
Oh, that's just the instruction size.
Yeah, the instruction size. I think it's the same number of instructions. It's not this. It's
Yeah, because that looks pretty
that looks
similar.
roughly equivalent, actually.
Yeah.
Oh,
Oh wait, no.
Two more there.
The mauve right after the JLL0. Line 72 on the bottom one and line E12 on the top one.
Ah,
Yeah.
yes, they're
That
different.
mauve is different.
Yes,
and there's an extra shift left in an or. Probably something to do with boxing.
More than likely.
Oh,
Yes.
I bet it has to do with boxing the return value or something like that. Or no.
I mean, it had to do that no matter what.
Yeah.
Yeah. So what is that nil? What is that nil it was doing in the other one?
I don't know. That's interesting.
Yeah, I don't even know what that nil would have. Oh, because it didn't have the return. You weren't actually returning anything.
Oh, yeah.
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 Okay.
It had to summon a nil up from the ether to return it.
But wait a second, though. If I did
Okay.
that, let me see. So if I did, if I did finally
return res.
Yeah. Then we should end up with the same.
res, do I have to also hint it?
No.
No.
Return res.
Okay. Yeah, and all that stuff.
61. There we go.
Yeah.
Okay. I was asking earlier if I needed to put finally return res, but I didn't get an answer, so I was like, okay, I'm assuming that,
Yeah.
So why are we
Alright.
still at 61 bytes when we had 64?
Because the previous one wasn't actually returning res.
We had to
It
add
was
the
just finally
instruction to
res.
return.
It was actually incorrect code.
Right.
Oh, okay, yeah.
Well,
I mean,
Oh,
it was correctly summing.
it was correctly
Yes.
summing. We weren't returning.
Actually returning it.
Right.
Right.
I'm just saying, it's still correct code.
So
can we try getting rid of that the? I just want to see if it still works.
okay. I think,
Yeah, I feel like
some
it should.
I. Yeah, it ought to.
yeah.
I mean, there's still the set Q, but, well,
Could we talk a little bit about this the, because that's the first use of the that I've actually
No
seen.
single float there.
Oh, no single
there.
quote? Okay.
No.
Because you already have the single float at the end.
Ah, got it.
Some I into res single float.
so can you double check that?
Yeah.
This is
Yeah,
something.
disassembly. Check the disassembly again.
Yeah, that's what I'm doing.
I'm
Give me
pretty
a second.
sure that should be the same. No. Oh.
61.
Oh, yeah, it looks the same.
It's the same.
Yeah. Well, we were, or at least I was concerned with that set Q in that particular situation, but it looks like it's fine.
Yeah, I think declaring the variable right. I think set Q screws with type deduction when there isn't any variable declared. Because I know that is a problem.
Can
But if
you
you actually declare the variable, it's probably fine.
could you get rid of the single float right after the I? I'm curious.
Okay, give me a second here.
If
Single-
I
that,
think that'll screw it up.
Yeah, I think this will start introducing some
Although
generosity.
it might not, given that it knows that the array is
right.
single float. So
Cool.
No.
Okay, so it looks like
Wow.
no,
That blew up.
Q,
That blew up significantly.
Yeah.
it's because of that Q.
That's interesting. So interesting.
It probably thinks it
Can you
needs to be.
make her expand that?
Okay.
If I were to guess, it probably is that it's allocating like just some arbitrary reference location for I now, and so it has to actually like move.
Put it to nil.
Yeah, or no, it has to move it on and off the stack or something like that, or box and unbox it, or
Give me-
because they are single floats, they can
No,
be
but-
represented as immediates, but they need
Yeah.
type information.
So
But see how nil or I isn't getting deduced.
Yeah.
Yeah, I starts as nil, and it's not getting a type declared.
Mhm.
So I must be it's T typed, which means anytime you assign to it or read from it, it has to add and remove the type tag bits.
What
right.
And that's
confuses
what
me
you're seeing
though.
there.
What confuses me though is that Loop isn't smart enough, or at least doesn't seem to be smart enough, to be able to deduce the type of I from the type of the
res.
array.
Yeah.
Because I feel like it should be in that
You'd think
situation.
that, but no.
Yeah. Well, and it could, right? So it already knows the type of the array. So I feel like it should be able to do that. In here.
Does Loop know that?
It should, because of the fact that if we collapse this,
that type information.
Oh, sure.
Because Loop is just a regular macro. So that type information wouldn't necessarily be available to loop itself. And then the fact that loop initializes I as nil means that later levels of compilation can't then go and realize that it needs to turn I into a single float variable.
Yeah. But
Loop
could.
If I may interrupt, I have a question here.
Loop could introspect the environment and figure it out, but I suspect that the person who wrote Loop was not the person who added environment introspection to SBCL. And I don't think anybody wants to mess with the implementation of Loop at this point.
Most Loop implementations are from
not standard
from the
compliant.
early 90s, based on MIT Loop, and little has been changed across implementations.
And we know that little has been changed because it remains standards incompliant.
Yes, it does.
That's
it's a really funky edge case, so it's not like it's standards incompliant in a way that'll bug you. But, strictly speaking, the MIT Loop was not compliant with the CL spec, and all the implementations that are based on MIT Loop, the reason we know that they haven't been updating their implementation of Loop, they're still incompatible with the spec. Known bug, no one wants to fix it.
About the form, as we just saw, the is just used, to help the compiler out for specific values if it can't deduce them.
Yeah.
Nothing more.
Actually, the way that they define the effect of declaring a type is in terms of the. It's not the other way around. The semantics for declaring something as being of declaring a variable as being of a particular type, it's defined as being equivalent to going to every spot where that variable is used inside that body of code and wrapping it in this type, that variable.
Okay, Elijah. What does truly the do?
No. No one needs to worry about that one. No.
I worry about that one every time I go to sleep.
now you piqued my interest. What does really do?
It's an SBCL specific internal.
It's a special form defined only for SBCL. It's an SBX, if I remember correctly, or is it an SBint? It better be an SBint.
Yeah, it's SBX. I'm pretty sure.
It's an X?
Yeah, I'm pretty sure.
Really? Okay. Rob.
Oh no, I think. Yeah.
Hold on. Let's try it. Like the. If I do the here.
No. It's called do SB-int.
Oh no, I think it is an X. So yeah.
Oh yeah. So nothing.
No. Truly dynamic extent is an SB-int.
Oh yeah. Yeah. No, that's a terrible one. Truly dynamic extent hurts me inside.
SB. Colon SB dash int, right?
No. SB-int is a package.
Oh, okay. Got it.
No, so
it's in SBX. So it's not. X colon truly the.
Yeah. For some reason, my.
Basically,
Sly weights the completions by frequency of use.
Yeah.
So here's the thing. Truly the is like is on regular safety levels what the is on high safety levels.
Oh.
So go ahead and this is one of my favorites. Put in a string there like hello worlds, or sorry, put like in I don't know, fix num, and then no put it.
Yeah, I'm good.
And then type out a string.
Okay.
Doesn't really matter. And then evaluate that.
Hold on, I'm going to put this in here.
Sure.
That might error. Yeah.
Oh yeah, because it's static.
Because it knows. Okay.
Yeah.
So here's the way to do it. Right. Here's the way that I like to show this one. Okay. Write a function. Write a defun.
Okay.
Right.
Repetitive.
So defun.
Safety 0.
No safety 0. That's the thing. Truly the on regular safety levels acts like the does on safety 0.
Okay,
that's
truly
the only difference.
Okay, I have.
So is there anything special that truly does? I mean,
no.
If you were to declare safety 0, would it do anything different?
No. Truly the is no more dangerous than regular the at safety 0. Where it's dangerous is at safety 3, it acts just like the does at safety 0.
Don't use it, please.
What?
Yeah.
That doesn't sound right. Wait a second. safety 3 means high
Yeah.
safety, and you're saying
Correct.
that it acts...
Truly the acts like safety 0 even at safety 3.
If you want to touch the SBCL compiler with safe code, that's on you, buddy.
Thanks.
Yeah. So do 1 plus
Okay.
in parentheses SBX truly the fix num A.
Okay.
And
Got it.
compile that.
Hold on. Compiled. Okay, it's compiled.
Yep. Now go over to your REPL
Okay.
and call it with a string.
What the...
This will scream at you, but
What the hell?
yeah. Never do that.
Oh my god. And hold on one second. You're saying that this, even if we declared safety 3 here, you're saying that it doesn't matter? It will still...
I would like to see the opposite. Giving it a fix num and declaring it a simple base string or something.
Oh, and dereferencing it?
You don't want to see
Yeah,
that.
you don't want to do that.
That will
That'll
probably crash.
Jesus Christ. That is hilarious.
Crash. Like let's be honest. Even this could actually crash your image.
Yeah.
Just so we're clear.
That's horrible, man. That's horrible.
Yeah. So the reason why that exists is so that SBCL's own macros, the built-in macros, right, can define something as being of a particular type at any safety level when they know that the type will be correct.
So it's something that should be internally
Right. It's something that you use when you've verified a type that the compiler can't deduce, and you know that it's safe to elide a type check even on high safety.
Why that's in the extension package instead of the
I
internal
don't know.
package?
It shouldn't be in the ext package. It should be in SBInt.
Yeah, that's interesting. I have just... this is why I like this group. This is why this is great. This is great. Let's see if we have questions here. Let me take a moment here.
There is actually a question, but I already answered it.
Yes, I noticed. Yeah, Sir Meow Meow. Sorry for, but I do agree with Elijah's recommendation. We do have that SpaceMax video that will give you an introduction on how to install and run it. But in general, if you're just trying to get started to learn the language quickly, the recommendation of using Protocol, I mean, I second that recommendation, really. I don't believe that there's any other dev environment that's currently out there that has Sly plus Emacs or Slime plus Emacs for common Lisp development. I wish
Michael is currently working on making Vim good enough to use.
Michael, you and I need to talk offline regarding that, because
He's been talking about it in editors quite a bit. You should hop on the Discord more.
Yeah, I need to.
Yeah, I would not recommend that. You just hear me complain a lot.
I mean, I'm on the Discord.
They're reasonable complaints. I get it. That's why I don't argue.
Editors itself is a very difficult thing to get right, but
Yeah.
for Common Lisp itself, it's also, you have the additional requirement that you need to also make it interactive enough to make the experience far more pleasant. Otherwise, you're going to get more complaints. And Sly, again, has spent a lot of years taking Slime's base and making it better. And
Slime was already a very good base to work with.
Right, exactly. So they added extensions to it. I wish there have been efforts, but to get to the kind of interactivity that Slime has, I will say that it's going to take a dedicated set of people, a dedicated amount of time.
Quite a bit of time. Yeah.
To actually go and write it.
I definitely agree.
We might get there eventually, but
I'm not going to get into it, but we'll talk about it offline.
Yes.
Yeah.
But so.
But yeah.
To get us back on track here, I mean, this really though brings up this example that we just kind of illustrated here. Kind of brings up one of the reasons why I started looking into this, just coming from my own personal experience. Why I started looking into how the type system kind of works and affects the assembly generation, because you saw here, like, there is a significant difference if you're not too careful, right?
Mm-hmm.
But you could, if you do the right things with annotating your functions, you could hint the compiler to do the right thing and generate far efficient code here. And I'm not saying that you should do this for folks who are listening and thinking that, oh, we should do this all the time. No. You need to profile. You need to find your bottlenecks and then put the appropriate hints in.
Something else worth noting, like I mentioned, that one optimization on one implementation might make another implementation worse. Also, different versions of the same implementation that you're optimizing could make it worse in the future. I've had this ongoing problem with this ping load library that just parses the ping image format. Every 3, 4, 6 months or so, it keeps getting worse, even though it has excellent type declarations. And that's because the SBCL compiler is changing over time, and you gotta keep that up to date. So whenever you're using type declarations, you really gotta make an effort to stay on top of it and make sure that your declarations are still doing what you expect them to do over time.
Right, and you need to, and that does require a bit more, I guess, a process if you're trying to write larger and larger systems, especially in Lisp, to ensure that as you move from one version to another version, that safety guarantees and speed guarantees are kind of put in place. But really, what's going to help you is to figure out a way to, like, profile your code and find your bottlenecks. I mean, this is all standard software engineering suggestions here that I'm mentioning, and then try to see if type annotations, which is what these are, will help actually improve code generation. That brings up one particular thing that I kind of alluded to in the past that I've been kind of deal with, and I'm going to put a future talk on this, but I'm going to mention it here briefly. Whether you're using Slime or Sly and Slime both provide some ability to look into your forms and do some basic profiling. I've looked at it in the past. Unfortunately, I don't remember some of the stuff that, but we can always check something out. There's ways of for example, turning on profiling with Sly profile package, which I think is still here, right?
Yeah, actually, Sly. I believe it only has a package for the deterministic profiler and not the statistical one in SBCL. I believe Slime is the one that has the other one.
So Sly does not provide Slime.
There's 2 profilers in SBCL.
There are. Hold on, let me go look at it. I have not seen those new profiles.
Yep, there's the deterministic profiler and the statistical profiler.
Yep, and Sly doesn't have the statistical one, or at least.
And I actually find that the statistical one can actually be a lot more useful. It just produces a lot more information you have to sift.
I think maybe next week, if it's okay with you, Ram, we should actually do a whole episode on the profiler, because it ties in nicely with what we're doing now.
Yeah, absolutely. And I think not next week, the week after. Next week is the 4th of July.
All right, week off. Okay.
And the week after that, we have something else happening.
Yeah, we have McClim. Just another announcement with everyone's on here. We got we have Jack Daniel, who is kind enough to actually give us an awesome overview, which I hope you can all join us for on McClim and hopefully he can answer my budding questions on on it, because I have a lot looking into it. But I think a couple of weeks after that, when we start, since this is a good point to actually bring in the profiler and actually showing people how to profile the code.
Yeah, we've never done anything with it at all on any of our streams.
No, we have not.
And I can't hurt to take some time to look at. Yeah.
Yeah, absolutely. And it also include things like, we can also start talking about, how to. Hopefully, at that point, we could start talking about how to like tune your Lisp code too as well for particular situations too. Yeah. So there are a couple of more, just a couple of things left really to discuss regarding declaring types and stuff. Really, this example that you've seen here kind of illustrates how to use it. And what I've shown above regarding deftype also is a way of you leveraging the hand counting integer. The only other thing that I need to show is really I think member, which is member and I think EQL.
We should talk about declaim and why you shouldn't use it that much.
Yeah.
Compared
well, let's take a step back. Declaim versus declare. All right, because
declaim is global.
Declaim is global. Declare is lexical, right?
Yes.
So technically, I shouldn't do something like this.
That won't do what you want it to do.
Okay.
No! Don't compile that.
It just did, and it says style warning. Declaim where declare was probably.
You know what you just did?
No, you don't want to do that.
You know what you just did?
What?
Yeah. Now you have to restart your image if you want to reset your safety settings.
Okay. All right. And
don't do that.
All right.
Okay. And we're back.
And we're back. Okay. So you
don't ever declaim optimize. It's a terrible idea. It doesn't do what you want it to do, and it'll step over everybody else's code.
I spent a week one time trying to find a problem with my code that should not have even existed and did not make any sense as to why it existed. Turns out one of the deep dependencies that my library depended on did that at the top level. It tainted the whole rest of the image with all the dependencies after it.
Okay, so I should just...
Do not do that, please, for the love of everybody's sanity.
PSA, please don't...
It's ill-defined as to what it will do across files, but in the past it has...
Don't declaim optimize anything, Yeah. Just don't do that. Don't do that.
Okay. So I'm writing that both has a note to everyone on the stream, but also for myself, because I'll probably end up accidentally doing it once.
There's no portable way to reset the global compiler settings after you've declaim optimized. Because there's no portable way of figuring out what the defaults are. And on some implementations, here's where it's really irritating. On some implementations, top-level declaims are actually scoped to the file they're in. On some, they're scoped to compilation units. And on some, they just affect the global environment, and it screws with everything. And so, just don't do that. It probably doesn't do what you think it's doing. It definitely doesn't do what you think it's doing portably. And it screws with everybody else's code.
So, is your just... I wouldn't even call it a recommendation now. It's a request, a heavy influence request from experience.
If you have a whole bunch of forms that you want to set the optimization settings for, there's a special form for that. It's called locally.
Yep.
Called locally.
You locally declare optimize, and then you give all of your forms inside the locally block.
So there's one thing we haven't talked about really yet, and for type optimizations, and that would be declaim, one of its intended uses, declaim f-type.
Ah, yes, declaim f-type. That's for specifically
declaring the types of arguments and return values of functions.
For functions, right?
Yep.
And that's so
in the function namespace.
in the function namespace. So I guess we could do it at the top. We could do it at the top
Really,
level,
the only
right?
thing I use declaim for is ftype and setting things inline or not inline.
So if
Yep.
you do ftype here and parens
Function. Parens.
fixnum, right? And then
Yes. And then
I think I could specify
Add
that
one.
for add one.
not hash coded,
Oh, not hash coded. Okay.
because it's specifically for functions in the function namespace anyway.
And I do I declaim ftype before I declare?
Yes.
Or, okay.
Yes.
Okay. Cool.
That should have printed a warning.
And it did not. Or
That's
no, it's because I
Weird.
restarted my Lisp image, right?
doesn't matter. That should have printed a warning.
What warning are you expecting?
No, it shouldn't.
That return value of that function is not a fixed num. It
Oh,
should
sure.
be complaining
It should
that
be.
you're defining the function incompatibly with its ftype.
Well, no, because it's on default safety levels, right? So I think it would complain to you at a higher optimization level
At a higher safety, maybe.
or higher safety. Yeah.
So
Or
if
lower-
I do this, if I do optimize safety 3 here,
That might not do it. I think you would have to wrap the defun in a locally optimized safety 3
okay,
if you
got
wanted
it.
to see it. Just because you need to make sure that you're actually doing it around the actual defun and not just inside the body of the function.
Okay, so declare.
Well, I guess what I'm because so here's what I'm thinking in there is that it's not complaining because it's going to error. So it's going to introduce a type check and it's going to error if it's not a fixed num. Whereas if you lowered the optimization level, then I think it would complain. Or sorry, lower the safety level. I keep saying the wrong word. So I don't think this is gonna warning you either.
Nope,
So
no warnings.
But try safety 0.
Nope.
See if you get anything there.
No warning.
Go ahead and disassemble, add 1.
Alloc.
Yeah, that might allocate a big num.
Interesting.
That's right.
Because then, yeah, that's flat out incorrect type declaration.
I said fixnum to fixnum, so it should have worked, but I don't think it's doing what it's supposed to be doing.
I mean, strictly speaking, anytime you don't follow through on a type declaration, you're invoking undefined behavior anyway. So it's not like SBCL is being incompatible here. It's just
Right.
I'm used to SBCL yelling at me when I do things that are obviously stupid.
Oh, well, it's funny, though. Okay, so
I mean, like,
this-
SBCL can see it. If you look at the described, it's got a distinction in the declared type and the derived type.
right.
It knows,
Yeah, it
and
does
it's
that.
not yelling at me.
Go ahead and evaluate the declaim again.
Okay, evaluated.
Yeah, that's
Don't worry.
weird.
Move the declaim inside the locally. After the declare. After the declare. 'Cause the declare has to come first.
Okay, hold on. So,
And before the defun. After the declare, before the defun.
hold on. Okay, so after the declare, before the defun. Right
Yes.
there. Okay.
File that, yes. No warnings. Wow.
Something is really messed up here.
Restart your image and run that little bit of code.
Okay.
I wanna see what happens. Because like that feels uncomfortable to me. And
You should get a warning or a compiler note every time you either reevaluate the declaim or the defun.
you ought to, yes.
Yeah.
Bring safety back up to 3
Okay, hold on one
in
second.
the locally.
Oops.
Oh,
Okay.
yeah, you need to load your stuff.
Yeah,
You need
give
to
me a
load your-
second. Let me go ahead and quick load.
And you haven't been in that package this entire time.
Yeah, I noticed. Why? I this is why. Oh, I deleted the in package for. I had that there earlier, and then, jeez. Okay.
Oh, that could have been why. You don't have an M package in your.
Yeah.
Yeah, but it would have just been
software
doing it in the CL user package, like we've been doing this
Yeah.
entire time.
Oh, true.
Workshop. Yes. There we go.
And then comma SS.
Yeah.
Yeah, there you go. Or reevaluate the def package and then comma SS, because it can't synchronize the package if the package doesn't exist.
Right. There we go.
There you go.
Now I can do
run
this.
that lovely.
No warnings.
No warnings. Okay.
And let me just do a describe here on add one. Still has the correct declared type, but it's still defining it as a signed
It
fixed.
knows they're wrong.
Ah,
It knows there's something wrong, but it's not warning you about it.
that's bad.
Well, it's
I
irritating.
don't.
It's
That's
standard
really weird.
compliant. It's just irritating.
Yeah, but
Mhm.
the assumption is a declaim
It's standard
F type.
compliant.
Yeah, it's standard compliant. I understand that, but if I see in the code declaim F type, fix them to fix them, right?
Mhm.
Kind of expect
Well, yes.
that the compiler will be like, wait a second, you say that this is
Not every compiler is that clever.
Yeah.
In this case, we have a compiler that is that clever and just isn't telling you anything. But not every compiler is that clever.
excellent. Good to know.
In this case, I'm just irritated at SBCL for not having a warning for that, or a note at the very least. But
I've never seen that occur before. That's just weird.
Well, I'm
What
running.
version?
I think the
yeah,
latest.
that's what I was going to ask. What version of SBCL are you running? Call Lisp implementation version.
Okay.
Yeah, it's a function.
Lisp
yeah.
implementation version 144.
Yeah, no, that's recent
pretty.
enough.
That's pretty ancient.
No, it's not that bad. I mean, it isn't recent, but it's not that bad.
Wait, what's the current SBCL version?
We're on 1.5.3, yeah.
I need
Soon
to
to be 1.4.
Yep.
ROS upgrade SBCL. I'm doing that behind the scene. Okay.
So, did you guys cover structs at all?
Nope.
No, we have not. But we should cover structs at some
Yes.
You're
point.
on 1.44, Ram?
Yes.
Um.
Why?
Oh, I'm just looking to
Seeing
see
if
when
you
that
can
was
reproduce it,
released.
maybe, or checking to see if any messages or bugs or stuff have been reported about that.
Install SBCL. The latest
probably
one
need
on
to-
Roswell is
1.44 was released about a year and a half ago.
yeah.
That's not too bad. Like, SBCL's type deduction hasn't changed a whole lot in that time.
I'm just
Well,
Roswell just is downloading 153, which is the latest that they have in their
Yeah.
repository.
Well, 1.4 hasn't actually been released yet.
So I'm just building it in the background. Hopefully, that will, when I restart my Lisp, it will go and use that latest one. So
yeah, there's been incredible improvements to the SBCL compiler since the version you installed, Ram.
well, yes.
Like Elijah said, it's not that long, but I mean, that long for a compiler, especially SBCL with monthly releases, is like an eternity.
Yeah, it is an eternity. I've been using Roswell as soon as it comes. Normally, as soon as the release comes out and I hear about it, I'm like, okay, let me see how long Roswell takes. About I think 1 or 2 weeks before it gets. It's possible for me to
It's usually
download
pretty
it.
fast.
Yeah, it's fairly fast, but it's it's a couple of weeks, so it's still between the release and when I can actually use Roswell install SBCL, ROS install SBCL bin to get the latest version. But
Just make sure you set the default so it doesn't try loading 1.44.
yeah, that's what I have to do. Yeah, but it has to first build it. It's building it in the background right now. It's building my Lisp image. So.
Are you even actually running Roswell right now in your REPL?
Yeah, I have it hooked into my Emacs.
But
for
that
the-
says
for the-
fly mREPL for SBCL, which would imply that it's your system-wide SBCL binary that it's running right now.
I thought I have this in my Emacs, but my SpaceMax buffer. My SpaceMax
Well, I mean, let's
configuration.
take a look at your SpaceMax config then.
SpaceMax. Where is it? Why are you not showing
Yep, tab.
it?
Init.l.
Yeah, it's in init.l. Yeah.
Yes, the multiple occurrences of the customized variables in the SpaceMax init file.
There it is, right here.
I remember. Oh, I see. Okay, I see. You just named them that way.
Yeah, Rob, you can actually install SBCL bin with Raspberry. So
no, he is. He's using SBCL bin.
Oh, he said he was compiling it, so I
no. So behind the scenes, when you do ROS install SBCL bin, it downloads it and builds.
It doesn't compile it.
It doesn't.
It's really quick.
No, it downloads a release.
Okay, hold on one second. I think I.
Yeah, if you install regular SBCL, that might compile it, and that'll take a while.
Let me just go ahead and restart my list here. Give me a second here. It just got done, so it should get whatever the latest one is. Behind the scenes, it's gonna take a minute because of the fact that
it has to recompile slot.
Yeah.
Slink. Has to recompile Slink.
Recompiling Slink behind the scenes.
And of course, on mine, there's a stupid bit of nonsense on some of my machines in my init file that actually does, asks for user input in the inferior Lisp buffer when I upgrade my SBCL. And so the first time I do that, I always have to go into my inferior Lisp buffer and answer some questions and then restart everything again.
Lisp implementation.
I need to remove that stuff from my init file.
Implementation version. Let's see.
That's the one.
153. There we go.
Okay, now let's try compiling that thing.
Okay. Hold on. Delete the buffer. Okay, there we go. Let me go ahead.
I would just take it out of the locally.
Dang it. Hold on. Let me load a couple things here. Where are you? Oh, dang it.
Them.
Yeah, that's fine. I'm okay.
And you're going to have to recompile Serapium if you do that, and that'll take a lot longer. Just FYI.
Yeah, and you don't really need it.
I don't need it. I'm not using it right now.
Just evaluate the one. You don't need the package.
Let me just actually delete this guy. So yeah, I'll just.
Well, I meant you don't even need to do that. You can just evaluate the one form.
Okay.
No warning.
Still no warning.
Wow.
Yeah.
Let me try reproducing that.
Describe.
So,
add
one equals fixnum x 1 plus x.
What? Locally, I locally did common Lisp : add 1. It's not showing anything.
Huh. Oh, are you in the right package in your REPL?
I should be. I mean, oh, hold on. It's not. It shouldn't be. Shouldn't matter. But I can do that. Give me a second.
No. Okay. Compile that package. Sync your REPL again.
Yeah. Now let me go ahead and compile
the
this.
thingy. Yeah.
And let me do a describe. Got it. Okay. And it's still giving me that idiotic range. Why? That's awesome. So
yeah, I can reproduce that. No warnings here.
That's interesting.
That's,
it's something that I guess we've just never noticed before.
So the question then becomes, when do we, I mean, I always thought you could use declaim f-type to force a certain function signature, or to enforce
it is forcing the signature as far as the users are concerned.
Okay. But...
So the call site is going to use that information.
Right.
What we're complaining about here is the fact that the definition isn't
complied
if x is a fixnum like you're declaring, and we're returning 1 plus fixnum, that means if we pass in the most positive fixnum, the return value might not be a fixnum.
Yeah, and that'll cause problems.
Which is kind of weird. I believe this actually should be reported to SBCL.
I mean, it's standards compliant, but I agree it ought to be recorded.
Oh yeah, I mean, yeah.
Absolutely. We just found a bug.
I mean, if you change,
I don't think it's a bug. I just think it's a missing feature. It should warn you in there.
It should.
Haha. Okay.
What's the problem?
So restart your Lisp
Okay.
and do them separately, without the declaim or the declare.
Restart the list. Take out the declare and then compile it.
No, just do the declaim in your REPL, and like restart your Lisp, copy the declaim to your REPL.
Okay.
Yeah, in your REPL, paste that.
Okay.
And compile the function. And like take the function definition, put that over in your REPL too. Okay, that's weird. Okay, go back to the declaim and rerun that one. I want to see what happens.
Run the declaim. Run the declaim again.
Oh wait, no, I'm wrong. Okay, I misread what I was seeing on my end. Yeah, that's weird.
Yeah, that's totally weird.
Yeah, no, it doesn't yell at you for that. I feel like it ought to.
Try changing the return value in the declaim to like
I already tried that on my
integer
end.
010 or something.
Oh, you can't decide the. Oh, in the declaim. Okay, yeah.
Here, like return the input or the output to integer 010.
The output.
The output.
Okay.
That is going to get you a warning, but it's not the warning you're looking for.
I'm confused. What it
That's just saying your two F types aren't compatible, but that's fine.
And then if I compile this guy.
Nope, no warning.
Yeah, still no warning. Well, other than I'm redefining it.
Right, yeah, but... So that's interesting.
Huh.
I'd like to yell at, how do you pronounce his name?
Stasets?
Yeah, that one. Stasets, yes. I've never had to pronounce it, so I'm not sure. Yeah, I'd like to yell at him for that one personally.
Alright. Okay. Yeah. What?
Like, I get it. Lisp isn't exactly known for the safety of its compilers, but at the same time, like, there's basic compiler safety, and this doesn't match that. This doesn't. Like, there's some very simple things that you really ought to do, and one of them is check the consistency of your type information. It's not doing that.
It is. Well, the thing is you said that the declared type is what's used at the API level, right? So as long as
declaim is used whenever you call it. The declare is used in the body for optimizations.
Okay, so but the declared type here in the describe is what declaim has said of what the function is supposed to be. Okay, so my question is that when you call it, this is already going to get. You're already going to get complaints from the Lisp compiler saying, "Hey, you passed in incorrect information" when it tries to, compile.
Well, no,
your use
you'll
of that
still
function,
call it with a fixed num. The problem is, if you call this function expecting it'll always return a fixed num, your code might optimize under that assumption, and then this code might return a big num one day, and ruin your day.
Got it. So this behind the scenes could actually introduce the overflow situation where it resets and you wouldn't even notice because your code wouldn't.
Well, a big num is an object. It's not a regular number.
Oh, okay. Oh, yeah. Right. That's right.
Yeah, and so instead of getting a number back, you'll get an object back.
Ah. Right. And then
you'll be trying to treat it like it's a fixed num, and that won't go well.
That won't go well at all.
No.
Okay, that makes sense.
Yeah.
Interesting.
Mm-hmm.
Well, SBCL folks, if you guys are watching this, the proof is in the pudding right here, so to speak. I think this is a legitimate concern, but as you said, it's still standards compliant, right?
Yeah,
so
because lying to the compiler about types is undefined behavior.
So yeah, okay, good to know. Well, there isn't much.
And the other thing is that, like, even though SBCL probably ought to do this because I put SBCL at a rather high standard, I wouldn't expect every implementation to do that for you. Like, SBCL does a lot of derived type information checking, and so that's kind of why I would expect SBCL to be able to do this. But an implementation that doesn't actually do type deduction to work out what the return type of the defun is, right? An implementation that doesn't have a derived type, it wouldn't catch that. It wouldn't know. And so, you can't expect your Lisp implementation to know that. The only reason I'm irritated in SBCL is that I know that it's working out the derived type, and then it's not bothering to check. It's already doing the work, and then it's not reporting to me when it's noticed there's a problem. That's the only reason I'm irritated. If it didn't have it in it to do the type derivation and actually deduce the return type, then I'd be like, oh, well, I guess it just doesn't have that, in it. And so it wouldn't be able to report that if it wanted to. And there are plenty of Lisp implementations that just don't have that, capacity. But SBCL does deduce the type, and then it doesn't check to see if it's consistent with the declared type for some reason. And that's irritating to me. So yeah. So, like, this isn't something I would expect any Lisp implementation to do, but the fact that SBCL is doing the type deduction anyway, and then it's not bothering to actually check, is bothering. It bothers me.
Well, it should rightfully bother you, because if you're going to do it, you need to do it, kind of in a consistent way with some expectation, right, with the expected use, and right now, this is kind of going against how you kind of expect it to work, and it's not.
Yeah.
And that's a bit, frustrating. I mean, when I looked at this, I didn't quite understand. When I first looked at this type, this ability to use declaim F type, I thought it was pretty cool. But then my confusion always were, well, there's what it's declared and then what the compiler derived, right? So the declaration, while that might help, with people correcting their code to an extent when they're actually developing, right? It's the derived type that's ultimately going to, dictate code generation, is what I think, right? And that could introduce a more, like you mentioned, a subtle bug that...
The derived type is what was used during the code generation of the function.
Right.
The declared type is what will be used during code generation of calls to the function.
Okay, but that even makes things more right, like, because when you're using the declared type for API usage, which will help to an extent, but it's really, there's still a bug, a subtle bug in the code generation.
There is a bug. Correct.
In your code.
Your code gen will be wrong, because the actual code generation you should have done should have been on the derived type. The reason why it isn't on the derived type is the derived type is more likely to change through function redefinition.
Right, but still, you would want at some point when you do a declaim F type for if you redefine the function because you have that information in the image.
It should warn you. Yes.
It should warn you, saying, by the way, this is the declared type doesn't match the derived type. You have some. Correct. This could introduce bugs. So,
yes, and that should be an easy check to do, but it doesn't do it.
Okay. Right.
Like, I feel like, I actually probably know enough about the SBCL internals at this point that if I really wanted to spend an afternoon, I could figure out where to insert that check. But I don't know if I have the afternoon to spend on it.
Right, certainly. Interesting. Well,
because, like, I know the data's there. Like, I know the data's there. Like, if you were to, for example, copy the declared type and the derived type to your REPL.
Okay.
Right?
Sorry. You want me to copy?
Copy. So actually, go down to your REPL. Go down to your REPL and do subtype P.
Subtype P. Okay.
And what you always want is for the derived type to be a subtype of the declared type.
Right. So I need to go to the derived type first.
Mm-hmm.
Copy this guy. Oops, not that. Let me just delete that and then paste, and then go up and get the declared type.
Now it's possible this won't work because some of the type operations don't like it when you try and use them on function types. But, I'm sure SBCL has a more general version of subtype P, even if, this doesn't. But yeah, okay, that's not right. Is that okay? Is that right?
That doesn't look right because
that doesn't
fix.
feel like that should be right. Okay, check that the return types. Do subtype P specifically on the return types for me, please.
Okay, give me a second here. Subtype P.
Because it's entirely possible that the default subtype P simply just doesn't bother to check subtyping relationships involving the contents of function types, because there are a lot of standard you need to quote the fix number.
Dang it. Okay.
There are a lot of standard functions for operating on types that just treat any function type. Just integer, not values.
Okay.
Just the integer bit.
And hold on,
And
let
then
me just
removing
delete
the
this
and
guy.
optional bit, and try that.
Looks like that looks
That's
right though,
interesting.
right? Because fixnum is negative that number to that number, isn't it?
But
Evaluate most negative fixed num and
Oh.
most positive.
No, yeah. So that's actually correct.
That's
Oh wait,
correct.
No, but-
because it's not inclusive, right? With the
No, it's not. It should be.
most negative fixed num and most positive fixed num, please.
Okay, is that a function?
No,
No,
just that.
it's just constant.
Okay.
Yeah,
most
that's just variables.
negative fixnum. Hold on, these are globals, so I'm assuming that.
No, they're not stars.
No, they're not.
Oh,
They're
okay.
constant.
And then most
Yeah, so-
positive.
Yeah,
so
that's
that-
already wrong.
The derived type is
No, that's
wrong.
fine.
Oh wait. Oh no, that's okay. You're right.
That's fine. The positive
The
one
positive is the 3.
Yeah,
Okay.
is
So the lower range is correct, but the upper range is
the upper range is wrong. Yeah,
exactly
that upper
yeah.
range is wrong.
Yeah, so that's what it is. The
Yeah, the
derived type is
derived
wrong.
type has been derived wrong. That's a bug.
Wait. The lower bound is does that
It's
match?
correct.
The
Yeah.
lower bound is right.
Yeah,
The upper
because-
bound is wrong.
They don't look
because
the
if you
same,
accept
though.
the fixed num, the lowest value that it can have is
Most negative
904. Yeah.
Yeah, it's 904,
So if you
but
add 1 to it, it's going to go up to 903.
oh, got it. Okay.
Yeah,
the
so the
issue is
lower
that the
bound is
upper bound
fine.
should be 904.
Exactly.
But the upper bound should be
Wow.
904, but
That's
it's not.
definitely
So
a bug.
that's a bug. That's a bug. Okay, well, guess what? We just discovered a bug we can report to Stassens.
We can give them video evidence too.
Yeah.
It's
yeah.
in the video. It's in
Yeah.
the video.
I mean, he'll want a minimal reproducible code sample, but still, we can be like, hey, look, we found this live on stream.
Oh, jeez. Awesome. Okay. So the upper bound is actually incorrect. Wait. It's 2 to the 62 minus 1, isn't it?
Something like that, yes.
That's right. Hold on. I have to.
Actually, it looks like, oh, that's interesting. That's interesting and weird. No, that's a problem. The derived type information is much more problematic than that.
Oops. I'm an idiot.
Because it I change out the 1 plus x for a times xx. I just tested this. I want to see if it's the same for you. This is going to make Michael and Wolf. This is going to make you both really uncomfortable.
Okay, what do you want me to do now?
Redefine the add one to be a times XX.
Okay.
To be a squaring function, basically.
Okay.
Copy out that definition and
Hold on.
keep it as add one because that's what we've already got the F type declared for, and screw naming conventions. But
okay, and then you want me to
declare it as fixnum. Yeah.
Fixnum
X.
Got it. And then you want me to do time XX. Okay.
Times XX. Yeah. Enter. Yeah. And then describe that. This makes it really obvious there's a problem.
Oh, wow.
Whoa, what is that? Mod 11? What the fuck?
Hold on one second. I'm going to make sure my declaim is correct here.
No. Reload your image, because something's gone wrong.
Right. Okay, restart list.
Oh, no! I know what it is! I know what it is!
Should I restart my list?
It has to do with the ordering. Because you've done the F-type declaration, it's actually working backwards from that.
Yeah, that's what's happening.
Yeah, because you have the F-type declaration first, then what it's doing is it's working backwards when it sees the return type. And it's assuming that you're writing code that's correct, basically.
Yeah.
Oh, wow.
Stupid.
Oh,
yeah,
man.
I see that now.
Yeah, because somewhere earlier in there, you must have declaimed the return type to be a hand-counting integer.
Yes, I did.
Yeah.
I did. Earlier, you wanted me to do that.
So since you declared the return type to be a hand-counting integer times a hand-counting integer, is positive, and so it restricted the bound further.
So
it only restricted the bound further instead of yelling at you for giving incompatible types.
So if I did this, okay?
Yes.
And then let's redefine this square function this way.
Yep.
And then describe
and now
it.
Describe. The derived type is now going to be unsigned to byte 62.
Yes.
Because basically it knows that the result is going to be positive, and it knows the result can't be larger than a fixed num.
Right.
And so it's just decided, well, the intersection of those two is unsigned byte 62, so that must be what the return type is. Which is irritating, to say the least.
Wow. It's
I guess
optimizing.
The TLDR on that is basically that the type derivation is making use of the declared F type as part of its deriving process.
Yeah.
Which is correct in a way, in that I could see you wanting to use that. For example, if the F type includes the variable types and those are not declared in the function, cool, use that. But for this, it seems not right.
Because what it's doing is it's actually basically what it is. No, here's the actual problem, right? The actual problem is there's no check to see, there's no warning being thrown that your return expression is of a broader type than that derived intersected return type.
Sure, got it.
Right?
I'll agree with that.
And It should check that. It should then, as it gets to all the end of this, and it derives what the return type should be, it should then check to see that, given these argument types, the return expression, is within the bounds of my derived return type. And it's not throwing a warning about that. That's a harder one to figure out a right spot to introduce a check for, though.
Yeah.
And so I can kind of see why there's no check in there for that, because that's a more irritating one to insert a check for. But I feel like it ought to, given it clearly has the information. And it's usually pretty good about that sort of thing. But oh well. I guess return types just aren't checked for their for consistency.
That's interesting. That does not that doesn't gel well.
Because it's taking, what it's doing is it's taking the return type derived from the return expression and intersecting that with the return type from the F-type declaration to come up with the actual derived type. Right? And then what it's not doing is going back and being like, wait a second, is the type just derived from the return expression actually within the bounds? And it's possible SBCL just doesn't have a good way of checking that, except in some really obvious stupid cases, like when the intersection produces a null type, like an empty type. Like, I bet if that intersection produces an empty type, it'll scream at you. But in other cases, it probably doesn't.
So if they're disjoint types specifically, then it will scream at you.
I suspect that if the result of that return expression and the declared F type are actually disjoint, it might yell at you in that one case.
Got it.
Because
that actually makes sense though. That makes sense though, because of the fact that if you can't derive it, right? Then it can't really it
like
sounds,
try returning a string from add one, see what happens.
Yeah. Okay. Give me a second. Let me just return.
Watch, this is not going to give a warning either. Like, okay, yeah, okay. So that's what it is. If the intersection produces an empty type, then it doesn't give you a problem. But if the intersection produces a valid type, it just assumes that's what you meant.
Okay. All right.
Which is tricky. Standards compliant, but tricky.
Yeah, that's.
I wish it gave you some better gave you some better warnings there. That's a feature request, I guess.
Yeah.
So we're back to feature request territory.
It's no longer a bug, but it's a feature request. All right.
Yeah.
There you go.
Yeah.
Okay.
I would like SBCL to actually check that the return expression falls within the final derived return type.
That's interesting. Okay. Actually, I like this. At least this should stay though. The ability for it to tell me. By the way, I'm gonna let this slide, but really, based on what you told me,
it should just be a warning.
Yeah,
it should just be a warning. It shouldn't be an error because you can redefine the function to correct the problem.
Right. And at the very least,
in a lot of cases, it probably is fine. It's not like fundamentally broken code.
Right.
It could be fundamentally broken. It's hard to say. It might be the F type that's wrong. Like, any time when it might be a completely unrelated bit of the code that's wrong, I argue it should be a warning and not an error.
Right.
Because we have style warnings for the things that are warnings in other languages. And we have redefinition here.
Right.
So, it might be the F type that's wrong. So it should at least be a warning telling you these two bits of your code are inconsistent. Fix one of them. But, it's not like the code's fundamentally broken.
Well, the code isn't necessarily. It's the entire type enforcement.
It's your whole program.
Yeah.
There's inconsistency across your whole program, but it might not be this one function that's wrong.
Right.
And so I consider that a warning, not an error.
Okay.
And the reason why, like, in a Lisp world, code that emits warnings shouldn't be trusted.
Yeah. Well, even in the compiled world, in general, if it has a warning, you may want to go and double check it.
Right, but at least in the compiled world, most warnings, you can reasonably ignore.
Yeah, like unused local variable.
Right.
That's fine. But
but in the Lisp world, an actual warning means there is something wrong. It just might not be the code that I'm looking at right now.
Yeah. So, for example, like it's going to be wrong for a certain range of inputs, but it's not wrong all the time. So,
and also, it might be the F type that's wrong. It might not be this function.
Right.
Right.
Certainly.
If the whole program is inconsistent, but it might not be this function that's wrong, that's a warning in Common Lisp.
Right.
But that's still an error in like a regular compiled language.
Right.
If like across a whole source file, this is inconsistent in a bad way, that's an error, whereas it might only be a warning in Lisp.
Well, that makes sense, though, because of the fact that you're like, well, you still want to continue working through it, Like you can, and you can redefine the function later after you use it.
It makes sense interactively. It just means that if someone's library includes a warning, you should treat that like you would treat an error in a compiled program.
Right.
Which is what Zach does.
I think that's a good practice that we should all like adhere to. So, um, okay, well, that's it for today. All I have.
Yeah, all we have time for. I mean, we could take some time to look at structs.
Do we have questions from folks who are on? George, Michael Gargano.
Oh, we actually have some questions on the YouTube live stream.
Yes, I've been looking at the YouTube live stream. A lot of it's related to, I think they're asking about Portical. Okay, question from regarding building executables in Portical. I don't believe you could do that.
Yeah.
In general,
Portical doesn't have a thingy for it. That is.
In general, regarding Lisp and building bundled executables, and I think we touched based on this a bit when we were going back and talking about ASDIF and how it can potentially generate executables, specifically images. You're running a Lisp image. You're interacting with that image, and you're running Sly and Slink within that image, and you're making adjustments to your code and experimenting within that. When you're normally thinking about a bundled executable, often for most folks coming from other languages, that kind of means that you're starting from scratch. You're building your entry point, and you're setting up your environment for that. For Lisp, there are the closest analogy to that I can think of is implementation specific. It depends upon which implementation you leverage as to how you would generate that executable. So, like for SPCL, for example, I think there's a dump image command within Lisp that you could leverage.
Save Lisp and die.
Yeah, save Lisp and die. Thank you. Save Lisp and die. Where you can actually specify the entry point, and then you can dump the image at that entry point. So when you load it up, Lisp knows what function to call specifically to actually start up the application. Would I recommend you leveraging that while you're developing your application? Well,
there's
yes
not really
and
any
no.
point to.
You
only really need that for final deployment.
Right. For final deployment, you'd want to do that. But even there, I would argue that you'd want to start with a clean image and build everything within it. Just because when you're developing within Lisp, you have a couple of third-party things that are just going to be there. Specifically, like Slink and if you're using Sly, or in Slime, I'm forgetting what their server is. Swank. You will probably want to get rid of those before you actually go and release it out into production. So my recommendation is to probably create a little script that you could leverage and to build the image.
You actually have to get rid of those before you deploy your image, because at least on SPCL you cannot dump an image with multiple threads running.
Right.
Yep.
Well, you can stop them.
Oh, sure.
All that, but you have to handle it either way, because you can definitely dump, and I have, multiple times dumped executables with Swank or Slink if I want to further debug them, while they're out there.
Right.
Right.
But when you're ready for production, I think having what I was trying to get into the habit of doing is writing simple Roswell scripts to set up how to generate the final executable for me. Other people have other approaches to doing that, but that's probably the easiest one that I could think of, where you essentially load your quick Lisp project and then and have Roswell actually build out the executable for you.
So there, like I said, there's a couple of different approaches. I haven't actually tried out using ASDF. So they have so ASDF actually has a thing for you to be able to dump an executable. I haven't played around with it. Chimera recommends it. But then the reason you would use that is because then your script that actually performs the build literally just has to have, ASDF load system and then just dump it.
Right.
Perform the build operation on it. So your build script literally is just calling into ASDF to dump the executable, which is easier than manually loading in the dependencies and then doing the dump.
Right. That makes sense.
But either way, it doesn't. The only thing that I would like to have improved isn't like a whole lot. All it is just to make it more obvious that's what you should do. It would be nice to have like a some sort of like application or script that is like in commonplace that you just run it and you tell it which system to dump, and it just does it.
Right.
So you don't have to write that part of it.
Right.
But even then, it just saves you like 2 lines of code.
Right. I mean, really though, the bottom line is it is implementation specific though, right? Like each implementation has its own thing. There are a couple of cross implementations tools like ASDF that gives you some capabilities, but I'm not as familiar with that. My approach since Roswell came out has always to leverage it, but that's just me. Other folks might have their own approaches, like Shinmera suggested, using ASDF to leverage that. I don't know what the right answer is to building a proper executable. That's
and we could maybe that might be a good session, but it's like you guys are saying, like it's not really something that's required if you're just developing. It's definitely more of a deployment issue than it is a development issue.
Right.
Like you take it into consideration while you're developing, like what you are building ultimately. If I'm just building a library, like I'm never gonna have to deploy it, because it's just a library. But if you're building that application, then
no, and you're right.
That goes into what the application is, and how it does its job.
In the past, I've introduced ASDF, at least in the ability to dump Lisp images. I think it does have some nice utilities that you can use. I used it, but those weren't real executables, so I didn't show how to create a full application using ASDF. That might be certainly something that we could bring up as a later topic. But the general notion of deployment, and this might be something that we should show, is implementation specific, and I could probably go through the common implementations and say, okay, here's at least something that works on SBCL and CCL, and maybe if I can get the ECL kind of working on my machine, ECL as well. But beyond that, I can't really kind of say this is what you should do. I don't have a big this is what you should do, like a recommendation at that level, just because I do what's comfortable for me to give me the executables that I need. And
there's a lot of details that you have to worry about when you're deploying an image. For instance, we mentioned you have to shut down Swink, or at least not load it. You also have to shut down any foreign libraries you're using, and then reload them in your initialization hook, because they might differ. Their location on disk might differ on your user's machines. Also, if you're referring to static assets like images or whatnot, the paths to those images might differ, because when you're referring to an asset in code, you're usually doing it based off the relative directory of your ASDF system, but your ASDF system doesn't exist in a deployed image scenario. So you actually have to have functionality to get it based off, say, argv0 or whatever, and stuff like that. There's just so much to worry about when you're deploying an image. My advice to you, if you're new to Lisp, worry about actually building something first, because then you'll have the experience to worry about all that later.
Yeah, I think once you get to a point where you're ready to deploy, that's a good problem to have, because you can actually try different implementations and figure out what's best for your particular application.
Building an image is not something you should worry about as you're learning Lisp, because it's only, as we mentioned, it's only relevant for when you're deploying an executable to users as an end product,
Right.
not during development.
Exactly.
And there's just so much involved with it. It's not worth the time trying to learn all that right now if you're new to Lisp.
Let's see, what other questions did we get? Okay, that's the same thing, and then okay. Thank you for asking that question, both Bruce Yount and Sir Meow Meow from the YouTube live stream. It looks like those are the only questions that we have. So, okay, until next week, I'll see you guys in a bit. Like I said, again, not next week. Next week is it's a holiday, so we're not going to be having the study group. And then the week after, we have our declaim discussion. So I'm hoping all of you can join me the week of the 13th, because it's going to be a pretty neat discussion on declaim, and hopefully I can finally get some questions of mine kind of answered on that. Bring your questions too if you guys want to know anything particular about declaim. Hopefully Jack Daniel can answer them. Maybe not so much the back end, but questions. But hopefully I'm crossing my fingers. So I'll see you guys on the 13th.
Cool. Well,
Bye.
great stream.
Bye.